Before there was light, before there were stars, before even time itself ticked forward, there was, well, that's the tricky part, isn't it? What does before even mean when there is no time? To ask what existed before the universe is like asking what's north of the North Pole. It sounds logical at first, but it doesn't quite make sense. Still, humans are stubborn creatures. We love asking impossible questions, and one of our favorites is, how did it all begin? To understand the creation of the universe, we first have to imagine the nothingness that came before it, or rather, the absence of everything. No space, no time, no matter, no energy. Just an infinite nothing that doesn't even have the dignity of being called something. If you're picturing a giant black empty room, that's still too much, because an empty room would require space, and space hadn't been invented yet. Wrap your head around that, and you've already earned your first gold star in cosmology. Now, scientists have their own way of describing this bizarre before. They call it a singularity, a point of infinite density and infinite temperature where the laws of physics as we know them break down. It's like the ultimate glitch in reality, the point where our equations throw up their hands and say, sorry, can't help you here. From this singularity, everything we know, galaxies, stars, planets, cats, memes, would one day emerge. But here's the mind-bending part, we don't actually know what the singularity was, or whether it truly existed in the way we imagine. It's a placeholder, a mathematical band-aid covering the wound of our ignorance. Philosophers and theologians, of course, have been pondering this long before physics had fancy equations. Ancient cultures had their own stories, the universe born from a cosmic egg, or sung into existence by a god, or emerging from chaos as order slowly took shape. In many ways, those myths were early attempts at answering the same question we're asking now. Why is there something instead of nothing? The difference today is that instead of priests or poets, we have cosmologists armed with particle accelerators and space telescopes. Yet even they admit that the moment, before the beginning, is still a mystery wrapped in equations, sprinkled with a little bit of humility. But let's be honest, when we say the universe was created, what we really mean is our universe. Because some scientists suspect that our universe might just be one bubble in a much larger multiverse. Imagine boiling water on a stove. Each bubble that forms on the surface is like a separate universe, expanding and eventually popping. Our bubble is just one of them, drifting in a cosmic soup we can't see. If that's true, then asking what came before the universe is like asking what came before this bubble. You might just find another bubble was already there. Of course, this idea is highly speculative, and some scientists roll their eyes at it, but it does highlight how slippery the question really is. So here we are, standing at the edge of time, staring into nothingness, trying to imagine the unimaginable. Maybe there was truly nothing, and the universe popped into existence out of pure quantum fluctuation, a cosmic lottery ticket that happened to hit the jackpot. Or maybe the universe has always existed in some form, cycling through births and deaths endlessly, like a phoenix that never gets tired of reinventing itself. Either way, the fact that we're here, talking about it, means that whatever happened, before the beginning, was powerful enough to ignite everything that followed. And this is where our journey truly begins. Because the moment we leave behind this abstract nothingness, we stumble into one of the most famous, most misunderstood, and most explosive events in all of science, the Big Bang. But before we get there, take a deep breath, because we're about to step from nothing into everything. And then, in a moment so short it defies human comprehension, everything changed. From that mysterious singularity, or from nothing, depending on how you look at it, the universe erupted into existence. But don't be fooled by the name Big Bang. It wasn't an explosion in space, because space itself didn't exist yet. It was the expansion of space. Imagine blowing up a balloon, except instead of air filling it, the balloon itself is stretching and carrying everything along with it. Now, instead of a balloon, picture all of reality expanding at once. Congratulations, you've just imagined the most violent, creative, and dramatic birth in history. In the first fraction of a second, something called cosmic inflation took over. The universe didn't just expand, it expanded faster than the speed of light. That might sound illegal according to physics, but the rule is that nothing in space can travel faster than light. Space itself, however, is allowed to bend the rules. So in less than a blink, the universe grew from smaller than an atom to something the size of a grapefruit, or maybe larger. Think of it as the ultimate zoom-out moment. The universe went from nothing there to holy cosmic pancake, there's a lot of stuff. As the universe expanded, it cooled. In those first microseconds, energy condensed into particles, quarks, gluons, electrons. It was chaos, a boiling soup of raw ingredients. If you could somehow peek inside, it would have looked like a fiery, seething storm, so hot and dense that light itself couldn't escape. This was a universe without stars, without galaxies, without anything familiar. Just pure energy and matter fighting for stability. Over time, quarks combined into protons and neutrons, laying the foundation for atoms. You could say that this was the universe's first recipe. Step 1, throw particles into a pot. Step 2, stir with gravity. Now, here's where things get funny. People often imagine the Big Bang as some kind of explosion they could watch from the outside. But there is no outside. If you were there, though you wouldn't have survived even a trillionth of a second, you wouldn't see the Big Bang happening in the distance. It would be happening everywhere, all around you. You were the Big Bang. Everything you see today, your hands, your phone, your dog, your favorite pizza, was once packed into that tiny, dense beginning. So, in a weird way, the Big Bang is not just the universe's origin story. It's your origin story too. As the universe kept expanding and cooling, something incredible happened. Roughly 3 minutes after the Big Bang, atomic nuclei began to form. Hydrogen, helium, and traces of lithium were created in a process called nucleosynthesis. These were the first building blocks of matter. But it would take hundreds of millions of years before stars and galaxies could emerge. For now, the universe was just a hot, glowing plasma sea. Photons, or particles of light, were constantly bouncing around, unable to travel freely. Imagine trying to walk through the most crowded concert mosh pit in history. You'd be slammed left and right, unable to make progress. That's what photons were experiencing. Finally, after about 380,000 years, the universe cooled enough for electrons to combine with nuclei, forming neutral atoms. This allowed light to travel freely for the first time. That light is still out there, stretched by billions of years of expansion, and we can detect it today as the cosmic microwave background. It's essentially the universe's baby photo, a faint glow left behind from its fiery childhood. And when scientists first detected it in the 1960s, it confirmed that the Big Bang really happened. But perhaps the most mind-blowing part of the Big Bang is this: everything we see today, from the billions of galaxies to the chocolate bar in your pocket, originated from that one moment. Out of unimaginable density and energy came order, structure, and eventually, life itself. If the universe had expanded just a little faster, matter would have flown apart too quickly for stars to form. A little slower, and gravity would have pulled everything back into collapse. Somehow, the balance was just right. It's almost as if the universe rolled perfect dice on its very first throw. And yet, the Big Bang is not the full story. It's only the opening act. Because once the universe began, the real question became, how did this hot plasma eventually lead to galaxies, stars, and planets? To answer that, we have to fast forward hundreds of millions of years to the era when darkness turned into light, the moment stars first ignited. But that, my friend, is a story for the next chapter. After the Big Bang, the universe was anything but glamorous. Imagine a pitch-black cosmic desert filled with invisible hydrogen and helium gas, stretching endlessly in every direction. No galaxies, no stars, no planets, just a cold and dark ocean of particles drifting aimlessly. This period is known as the Cosmic Dark Ages, and trust me, it lived up to its name. If you were somehow dropped into this early universe, you'd see nothing. No twinkling lights, no friendly Milky Way, not even the faint glow of a distant star. Just darkness. It was like the universe had created a stage but hadn't yet turned on the spotlight. But nature hates boredom, and gravity was about to put on the greatest show in history. Over millions of years, tiny fluctuations in density, those little imperfections left behind in the cosmic microwave background, started to grow. Areas with just a little more matter pulled in more gas, becoming denser and denser. Slowly, invisibly, the seeds of structure were planted. Imagine drops of rain sliding across a window, clumping together into bigger droplets. That's exactly how gravity worked on hydrogen and helium gas. As these clumps grew, the pressure at their centers increased. Hydrogen atoms began crashing into one another at such extreme speeds that they fused together, releasing immense amounts of energy. And just like that, the very first stars in the universe were born. These stars weren't like the friendly yellow sun we know today. No, they were massive, ferocious giants, hundreds of times larger than our sun, burning incredibly hot and living incredibly short lives. They were the rock stars of the cosmos, bright, loud, and destined to burn out fast. When those first stars lit up, they ended the cosmic dark ages. For the first time, light pierced through the universe, shining across billions of light years. Imagine the darkness of a theater right before a concert begins, and then suddenly the stage lights explode in color. That's what the universe experienced. These first stars didn't just make things bright, they transformed everything around them. Their radiation ionized the hydrogen gas, ripping electrons away from atoms and making the universe transparent to light. Thanks to them, the cosmic fog lifted, and the universe truly became visible. But these stars weren't just pretty lights in the sky. They were factories of creation. Inside their blazing cores, nuclear fusion created new elements. Hydrogen fused into helium, helium fused into carbon, and heavier elements like oxygen and iron were born. When these giant stars eventually exploded as supernovae, they scattered these elements across the universe, seeding the raw materials for planets, life, and everything we know. So the iron in your blood, the calcium in your bones, and the oxygen you're breathing right now all came from the death of these first stars. In other words, you are literally made of stardust. It's also worth noting that without these first stars, galaxies would never have formed. Their immense gravity helped pull gas into larger and larger structures, laying the foundation for the vast cosmic web of galaxies we see today. The universe transformed from a silent, empty void into a bustling arena of light and matter. Stars clustered together, galaxies swirled into existence, and cosmic architecture began to take shape. What started as random gas clouds became the stunning spirals and glittering galaxies that paint our night skies. And while those first stars are long gone, they burned out billions of years ago, their fingerprints remain. Astronomers can still detect their influence in the composition of later stars, in the faint background light of the cosmos, and in the galaxies that formed from their ashes. In a way, those stars were the universe's first storytellers, writing the opening chapters of a narrative that would eventually lead to us sitting here, wondering how it all began. But the story doesn't stop with stars. Because once these massive stellar giants exploded, they left behind mysterious and terrifying remnants, black holes, neutron stars, and cosmic chaos. These leftovers would shape galaxies, drive evolution, and open up entirely new questions. So, as we close the chapter on the first stars, we step into an even darker, stranger realm, the birth of the first black holes. When the first stars ended their lives in violent explosions, they didn't just scatter the ingredients for planets and life. Some of them collapsed inward, creating the most mysterious and terrifying objects in the cosmos, black holes. If stars were the fireworks of the universe, then black holes were the vacuum cleaners. Except these cosmic vacuum cleaners don't just suck up crumbs, they can swallow stars, planets, and even light itself. Welcome to the universe's dark side. So what exactly is a black hole? Imagine a star so massive that when it dies, gravity wins. Normally, explosions push outward, but if the star is heavy enough, nothing can stop gravity from pulling everything inward. The core collapses until it's infinitely dense, forming a singularity, a point where physics, as we know it, breaks down. Around this point is the event horizon, the invisible boundary you absolutely do not want to cross. Why? Because once you're inside, there's no escape. Not even light, the fastest thing in the universe, can outrun the gravitational pull. To put it simply, black holes are like cosmic prisons, with one rule: once you're in, you're never getting out. Now, these first black holes weren't small. Because the first stars were giants, their black hole children were monsters too. Some of them grew rapidly, feeding on surrounding gas and merging with one another. In just a few 100 million years, they became the seeds of supermassive black holes, the colossal beasts we find at the centers of galaxies today. Imagine something millions or even billions of times the mass of the Sun, crammed into a region smaller than our solar system. That's not just scary, that's absurd. But here's the wildest part: without black holes, galaxies might not even exist. As they formed, black holes provided gravitational anchors, pulling matter into swirling disks and helping galaxies take shape. Instead of being cosmic destroyers, black holes turned out to be cosmic architects. They guided the universe's structure, like hidden puppet masters pulling the strings. So the very things we often imagine as villains were actually essential to creating the grand beauty of the cosmos. Talk about a plot twist. Of course, black holes are also incredibly weird. If you fell into one, from your perspective, you'd pass the event horizon and plunge toward the singularity in seconds. But to an outside observer watching you fall, you'd appear to slow down, stuck on the edge of the event horizon forever, gradually fading into darkness. Time itself bends around black holes. They are like natural laboratories where the rules of space, time, and reality get rewritten. And the fact that these bizarre objects existed so early in the universe is a puzzle scientists are still trying to solve. How did supermassive black holes grow so big, so fast, in such a young universe? It's a cosmic mystery that keeps astronomers awake at night. But let's not forget the dramatic flair of these monsters. When gas and matter fall into a black hole, they don't just vanish quietly. They spiral inward at incredible speeds, heating up and releasing colossal amounts of energy. This process creates blazing jets of radiation that can stretch across galaxies, outshining trillions of stars. So ironically, even though black holes themselves are invisible, their feeding frenzy makes them some of the brightest objects in the universe. The cosmic boogeyman also throws the biggest light show. The first black holes marked a turning point in cosmic history. They weren't just byproducts of dying stars. They were engines that shaped galaxies, influenced star formation, and maybe even determined how the universe would evolve. Without them, we wouldn't have the Milky Way. Without them, we wouldn't have the conditions for life. Without them, we might not even be here. So while black holes sound terrifying, you actually owe your existence to them. Creepy, right? But as much as black holes shaped the universe, they were only part of the story. Because while some stars collapsed into darkness, others came together to form brilliant new generations of stars and galaxies. The universe wasn't just a place of destruction, it was also becoming a place of creation, complexity, and order. And the next chapter of our story takes us there, the birth of galaxies themselves. With the first stars blazing and the first black holes lurking in the cosmic darkness, the stage was set for the universe's next masterpiece, galaxies. Think of galaxies as the cities of the cosmos, vast communities of stars, gas, dust, and dark matter all held together by the invisible hand of gravity. If the early universe was like scattered villages of lone stars, galaxies were the bustling metropolises that gave the universe structure, beauty, and identity. Without galaxies, the night sky would just be a random scattering of stars instead of the breathtaking spirals and glittering clusters we admire today. So how did these cosmic cities come into existence? It all started with gravity pulling together massive clouds of gas. Over time, these clouds condensed into larger and larger structures, forming dense regions where stars began clustering together. But there was more than just ordinary matter at play here. Dark matter, the mysterious, invisible substance that makes up most of the universe's mass, played a starring role. While normal matter glowed, burned, and exploded, dark matter quietly provided the scaffolding. Imagine building a skyscraper. You need steel beams hidden inside the walls to hold it up. In the same way, galaxies needed dark matter halos as invisible frameworks to stabilize and shape them. Without dark matter, galaxies would have never come together. As galaxies began to form, they weren't the elegant spirals or majestic ellipticals we see today. No, the first galaxies were chaotic, messy, and clumpy, like cosmic toddlers just learning how to walk. They were small, irregular, and often colliding with one another in violent mergers. But instead of destroying them, these cosmic collisions actually helped galaxies grow bigger and more organized. When two galaxies smashed together, their stars mostly passed each other unharmed. Space is, after all, mostly empty, but their gas clouds slammed together, sparking waves of new star formation. Out of cosmic chaos came bursts of creativity. Over billions of years, this process of merging and growing shaped galaxies into the grand structures we know. Some became graceful spiral galaxies, with elegant arms swirling outward like pinwheels. Others grew into massive elliptical galaxies, giant glowing blobs filled with countless stars. And scattered among them were smaller dwarf galaxies, the tiny towns of the universe. Each galaxy developed its own personality, shaped by its history of collisions, star formation, and the activity of its central black hole. It was like watching a cosmic drama unfold, with galaxies playing the main characters. Of course, galaxies didn't exist in isolation. They gathered into clusters and superclusters, weaving together into a vast cosmic web that stretched across the universe. Imagine an endless three-dimensional spiderweb, with galaxies sparkling like jewels along the threads. This cosmic web became the large-scale structure of the universe, the architecture that still defines it today. So when you look up at the Milky Way in the night sky, you're not just seeing stars. You're seeing one city in an enormous cosmic network, one glowing node in the great web of existence. But galaxies weren't just beautiful to look at, they were also crucial for life. Without galaxies, stars wouldn't have clustered together long enough to forge heavy elements, and planets like Earth could never have formed. Galaxies created stable environments where stars could live long, quiet lives, perfect for giving planets billions of years to evolve complex chemistry and eventually life itself. In a sense, galaxies were the cradles of possibility, nurturing the conditions that would one day allow us to look back and ask, how was all this created? And speaking of our place in all this, the story of galaxies wouldn't be complete without introducing our own home, the Milky Way. A sprawling spiral galaxy with more than 100 billion stars, the Milky Way is where our Sun, Earth, and every human story ever told resides. But how exactly did our galaxy come into being? To answer that, we'll have to dive into the next chapter, where the focus shifts from the universe's grand architecture to the birth of our very own cosmic neighborhood. As galaxies across the cosmos were being born, merging, and colliding in a spectacular dance of gravity, one galaxy in particular began to take shape, a galaxy that, billions of years later, we'd call home, the Milky Way. Our galaxy wasn't created in one single moment of brilliance. No, it was built like a patchwork quilt, piece by piece, over billions of years. Imagine a cosmic construction site, where the blueprints keep changing, the builders are colliding into each other, and the materials arrive late but somehow, miraculously, the skyscraper still gets built. That was the Milky Way's childhood. In its earliest days, the Milky Way wasn't the majestic spiral we see in telescopes today. It was more like a chaotic toddler throwing blocks around the playroom. Small star clusters and dwarf galaxies collided and merged, feeding the growth of something bigger. Each collision brought new gas, new stars, and sometimes even black holes, adding to the galaxy's structure. Over time, these chaotic mergers settled down, and the Milky Way started to spin, flattening into a disk like pizza dough tossed in the air. This disk became the foundation of the spiral shape we recognize today. Dark matter again played a critical role. Like an invisible skeleton, a massive dark matter halo surrounded the forming Milky Way, keeping it stable. Without that unseen structure, the galaxy might have torn itself apart under the violence of constant mergers. Instead, the dark matter halo acted like a cosmic safety net, holding everything together while the Milky Way slowly grew into something elegant. And as it spun faster, arms of stars began to stretch outward, curling into graceful spirals, the beginning of the stunning pinwheel design that makes spiral galaxies so mesmerizing. But the Milky Way didn't rise in isolation. Around it, smaller galaxies orbited like satellites, some of which were swallowed up entirely. Even today, the Milky Way is still digesting little galaxies like cosmic snacks. Astronomers have found streams of stars scattered across our sky that are the remnants of smaller galaxies the Milky Way gobbled up long ago. It's like finding crumbs in the kitchen, you just know someone's been eating. The Milky Way is still hungry, and in a few billion years, it will collide with the Andromeda Galaxy in one of the most spectacular cosmic events imaginable. Don't worry though, you won't be around for it, unless you've figured out immortality by then. At the heart of the Milky Way lies something truly monstrous, Sagittarius A*, our central supermassive black hole. For a million times the mass of the Sun, this beast sits quietly now, but in the past, it may have been far more active, spewing jets of radiation as it feasted on gas and stars. Even today, it shapes the motion of stars in the central bulge of the galaxy, holding the Milky Way together like a gravitational anchor. So yes, our galactic home has a monster in the basement, but without it, the house wouldn't stand. The Milky Way eventually grew into a sprawling city of stars, now home to more than 100 billion of them. From within, we see it as a hazy, glowing band stretching across the night sky, but if you could step outside, you'd see a breathtaking spiral galaxy, with arms glittering with stars, clusters, and nebulae. Every single human story, every dream, every laugh, every heartbreak, all of it has unfolded on a tiny planet orbiting an ordinary star, tucked away in one of those spiral arms. It's humbling and a little mind-blowing to realize that the Milky Way isn't just a galaxy, it's our galaxy. But the story doesn't stop here. Because inside this great galactic city, somewhere in its suburbs, our sun was about to be born. And with the sun would come a family of planets, one of which would grow oceans, mountains, forests, and life that could wonder about its place in the cosmos. The rise of the Milky Way was the stage setting, but the spotlight was about to shift. The next chapter belongs to the star we call our own. Inside one of the Milky Way's spiral arms, about 4.6 billion years ago, a quiet drama began to unfold. It didn't look like much at first, a huge cloud of cold gas and dust drifting through space, minding its own business. But in the universe, even quiet clouds have secrets, and this one was destined for greatness. Somewhere in that cloud, the story of the sun, our sun, was about to begin. The trigger might have been something dramatic, like a nearby supernova explosion sending shockwaves rippling through the cloud. Or maybe gravity itself just decided enough was enough and started pulling the gas inward. Either way, the once stable cloud began to collapse under its own weight. As it collapsed, the material swirled, spinning faster and faster, like a figure skater pulling in their arms. The center of this swirling cloud grew denser and hotter, forming a protostar, the baby sun. At this stage, our sun wasn't the calm, golden ball of light we know today. It was more like an angry toddler throwing tantrums, blasting out strong winds and flares. But deep inside, something incredible was happening. As the temperature and pressure in the core climbed higher and higher, atoms of hydrogen began fusing into helium. In that instant, nuclear fusion was born in the sun's heart, releasing an unimaginable amount of energy. Our star had officially turned on. The sun wasn't just a collapsing ball of gas anymore, it was a self-sustaining fusion reactor, glowing with the light that would one day nurture life on Earth. But the sun wasn't alone in its birth. Around it, the leftover gas and dust formed a spinning disk, like cosmic pancake batter swirling in a bowl. Over millions of years, clumps began forming in this disk, colliding and sticking together. Some grew larger, becoming planets. Others remained small, becoming asteroids and comets. This was the solar system in the making. The sun stood proudly at the center, while its children, planets, moons, and countless smaller objects, began to take shape. It was a cosmic family portrait slowly coming together. The young sun went through a turbulent childhood, blasting the newborn solar system with intense solar winds. These winds blew away much of the leftover gas and dust, clearing the neighborhood and giving the planets room to settle into stable orbits. If not for this cleansing, Earth might have ended up smothered in too much gas, looking more like Jupiter than the blue and green paradise we call home. The sun was tough love at its finest. As billions of years passed, the sun matured into the stable, yellow star we see today. It's not the biggest star, nor the smallest, it's a medium-sized star, a G-type main sequence star to be precise. But for us, it's perfect. Its steady energy has provided warmth and light for billions of years, allowing life to evolve and civilizations to rise. Every breath you take, every meal you eat, every laugh you share, all of it is powered by energy that began in the heart of the sun. It's the ultimate provider, the silent engine running behind every human story. And here's a fun twist, stars like the sun are cosmic recyclers. The very atoms in your body, carbon, oxygen, nitrogen, were forged in the hearts of older stars that died long before the sun was born. When those ancient stars exploded as supernovae, they scattered their elements across space, enriching the cloud that eventually formed our solar system. So in a sense, we are made of stardust, lit up by the light of a younger star. We carry the history of the cosmos in our bones, while basking in the glow of our local star. The sun's birth wasn't just the start of a star, it was the foundation of everything we know. With its light came energy. With its stability came time. With its presence came the possibility of life. The next step in this story belongs to a very special planet orbiting in just the right spot, Earth. But before we dive into the birth of our world, let's pause to appreciate the star that made it all possible. Without the sun, there is no Earth, no oceans, no forests, and certainly no you and me. The sun is the silent hero of our cosmic tale, and its rise set the stage for life's grand entrance. As the newborn sun blazed at the center of the solar system, the leftover material swirling around it slowly began to come together. Tiny dust particles, no bigger than grains of sand, collided and stuck like static-charged socks clinging after laundry day. Over millions of years, these dust grains formed pebbles, pebbles became rocks, and rocks smashed into each other to form giant boulders. This wasn't a calm process, it was more like a cosmic demolition derby, with planetary embryos crashing, merging, and sometimes shattering apart. And in the middle of this chaos, one world began to take shape: Earth. In its earliest days, Earth didn't look anything like the blue and green paradise we know today. It was a glowing ball of molten rock, covered in oceans of lava and constantly pummeled by asteroids and comets. The surface boiled with heat, not only from impacts but also from radioactive elements buried deep inside. If you had tried to visit early Earth, you wouldn't find beaches or forests, you'd find fire, brimstone, and probably regret your travel choices immediately. But this fiery beginning was essential. As the young Earth formed, heavier elements like iron and nickel sank to the center, creating the core. Lighter materials floated upward, forming the mantle and crust. This process, called differentiation, gave Earth its layered structure. And that iron core? It would later generate a protective magnetic field, shielding the planet from the sun's deadly radiation, a feature that would prove crucial for life. Meanwhile, collisions with other planetary embryos continued to shape Earth. In fact, one of these collisions was so massive, it changed everything. A Mars-sized object, often nicknamed Theia, slammed into the young Earth with unimaginable force. The impact was catastrophic, melting rock, blasting debris into space, and nearly destroying both bodies. But from this violent event came something beautiful: the Moon. The debris thrown into orbit around Earth eventually coalesced into our natural satellite. So every time you look up at the Moon, you're seeing the scars of Earth's wild, violent youth. As the chaos settled, Earth began to cool. Volcanic eruptions belched gases into the atmosphere, creating a toxic mix of carbon dioxide, methane, and ammonia. It wasn't breathable for humans, but it was the first step toward an atmosphere. Comets and asteroids, carrying ice, bombarded Earth, delivering water that pooled into the first oceans. Imagine that, every drop of water you drink may have started its journey riding inside a cosmic snowball billions of years ago. The oceans became Earth's defining feature, transforming it from a hellish lava world into a blue planet shimmering in the sun's light. Still, Earth wasn't exactly hospitable yet. Its skies were choked with volcanic smog, lightning flashed constantly, and meteor impacts were routine. But beneath the chaos, the stage was being set. Stable land masses began to form. Oceans grew deeper. The magnetic field flickered into existence, protecting the surface from the worst of the sun's radiation. For the first time, Earth was not just a molten ball of rock, it was a world with the potential for life. This transformation was extraordinary. Out of random collisions and cosmic violence, a planet emerged with just the right size, the right composition, and the right distance from the sun. Too close, and Earth would have become a scorched desert like Venus. Too far, and it would have been an icy wasteland like Mars. But Earth found itself in the perfect Goldilocks zone, where liquid water could flow and life could someday thrive. Whether by luck, destiny, or cosmic coincidence, our home world was born in just the right place at just the right time. The Earth we know today, with its mountains, oceans, forests, and skies, didn't appear overnight. It was forged in fire, sculpted by collisions, and tempered by time. Yet in its rocky surface and watery seas lay the ingredients of something miraculous. Because soon, on this once fiery world, life itself would awaken. And with it, the universe would begin to look at itself through curious eyes. After billions of years of fire, fury, and cosmic collisions, Earth finally calmed down enough to offer something extraordinary: stability. The molten seas of lava cooled into solid crust, water filled the great basins, and thick clouds wrapped around the sky. For the first time, Earth didn't look like a hostile battlefield. It looked like a home waiting to be filled. But still, one enormous question remained: how do you get life out of rock, water, and gas? The answer lies in chemistry. Early Earth's oceans weren't just pools of water, they were bubbling cauldrons of organic soup. Volcanic gases filled the air with carbon dioxide, nitrogen, hydrogen, and methane. Lightning storms cracked open the sky with massive bolts of energy. And within this chaos, molecules began to dance. Simple compounds formed more complex structures. Amino acids, the building blocks of proteins, began to appear. These were the alphabet of life, assembling slowly into the first words of biology. Some scientists call this the primordial soup hypothesis, where the ingredients of life brewed in the oceans until the recipe was just right. Others suggest life might have arrived from space, delivered by comets or asteroids carrying organic molecules, a theory known as panspermia. Whichever path was true, the result was the same: Earth's lifeless chemistry was about to make the leap into biology. Somewhere in a shallow pool, perhaps warmed by volcanic heat or struck repeatedly by lightning, the first microscopic bubbles of self-replicating molecules formed. These primitive structures weren't alive in the way we think of life today, but they had one crucial ability: they could copy themselves. Replication meant persistence. Persistence meant evolution. And evolution, given time, would mean everything. Slowly, these molecular pioneers evolved into the first cells, tiny, single-celled organisms drifting in the oceans. They had no eyes, no brains, no mouths, but they were alive. They ate, reproduced, and adapted. The Earth that had once been nothing more than rock and water now had something entirely new, life. If the universe had a soundtrack, this is where the music swelled. These microbes didn't just survive, they transformed the planet. Some of them discovered photosynthesis, a trick that allowed them to use sunlight to make energy. The waste product of this process? Oxygen. At first, oxygen was toxic to many early life forms, but over time it reshaped the entire planet, filling the atmosphere and paving the way for more complex organisms. Without these tiny microbes, you and I would never be here. They were the unsung heroes of evolution, the original architects of the world. Think about it, every tree, every animal, every human being traces its lineage back to those first cells. When you breathe, you're taking in oxygen made possible by their invention. When you eat, you're using energy that started in the same chemical pathways they pioneered. We are living testaments to the creativity of chemistry and the power of time. The dawn of life on Earth wasn't just a turning point for our planet, it was a turning point for the universe. For billions of years, the cosmos had been full of stars, galaxies, and planets, but none of those things could wonder about their own existence. Life changed that. Life meant curiosity. Life meant meaning. With the first spark of biology, the universe gave itself the ability to ask questions like, how was I created, and, are we alone? From this humble beginning, evolution would continue its relentless march, creating creatures stranger and more complex than anything we can imagine. Eventually, it would give rise to us, storytellers looking up at the stars, trying to piece together where we came from. But it all started here, in the silent oceans of a young Earth, with tiny molecules that learned how to dream. And that is the true beauty of this cosmic story. Out of chaos came order. Out of rock and water came biology. Out of blind chemistry came consciousness. And now, billions of years later, you and I sit here, telling this story, proving that life's first whispers have turned into voices that echo across the universe. The dawn of life wasn't the end of Earth's journey, it was the beginning of a saga that still continues today. And maybe, just maybe, out there in some other world orbiting a distant star, the same story is unfolding right now.